always be a possibility that they will encounter rough seas, just like what happened to our project. In our project, during our integration testing phase, we encountered a problem. And what the project did, was to use the SWQC processes that we have learned in order to solve this problem. And what we did was to improve JavaScript bug detection and prevention through UT and DD scope enhancements. So before going further to our SWQC story, a brief background of our project. SWE Portal is a software as a service via World Wide Web, and it offers these free tool services as shown here. And the main objectives of this group is to improve quality, improve productivity, and reduce overtime in order to make employees happy. So this project of ours were started by MSDC way back at 2008. It started as a research project, and then it gradually evolved into an agile project over the years, until recently, on this current iteration, we adopted the waterfall model, as shown here. So our project has 3 milestones. Milestone 1 was already completed. Milestone 2 and 3 are still ongoing. Milestone 2 is currently on the integrated testing phase, while milestone 3 is still on coding phase. Now on milestone 1, the project encountered a problem in the integration testing phase. And what we did was to use the SWQC processes in order to solve this problem. And so we plot the SWQC schedules, we set activities for this, like the QCD activities, RCAs, setting of targets, setting of action plans, implementing solutions, and planning for standardization of our solution. So what is our problem? The project has found 185% more bugs than planned during milestone 1 integration testing phase. 85% of these actual IT bugs are JavaScript bugs, which should have been detected during unit testing and should have been prevented in the upstream phase. So how did we realize this is a problem? We tried to verify our data, and what we have found out was this. During our integration testing, the planned bugs was only 7. However, the actual bugs found was 20. That's 185% more than what was planned. And these bugs, they cause blocking bugs. They are blocking bugs. They cost man-hours to fix, and they delay the release. So going further, we analyze what are these 20 bugs. We use the root cause analysis. And what we found was that 85% of these bugs are JavaScript bugs, and only 15% are integration bugs. And these JavaScript bugs were not even stated in the integration testing specification. However, they were found due to IT execution. So what is the problem with JavaScripts? In order to answer that question, we have to first look to a diagram of our system. Our system consists of 2 sides, namely the server side and the client side. For the JavaScripts, they are found in the GUI. Then the GUI is in the client side. And the GUI is just a single entity of our integrated system. So in order to analyze further, we have to use another SWQC tool, which is the Process Network Analysis, the PNA. Why we use the PNA? Because we want to know the input, output, and the processes of each phase. And we try to first look at the integration testing phase. We found that in integration testing phase, the process that we used was okay. However, we were in doubt regarding its input. The input for integration testing phase is the integration testing specification documents. The ITS docs, they describe the testing for the whole integrated system. However, for JavaScripts, they are specific. They are only part of of a single entity, and so they should be found on a more specific document, which is the detailed design. And if it is found in the detailed design, then it should, in its counterpart testing, should be on the unit testing. So going to the unit testing, we found that bugs found in bugs found in IT exist that what was planned. So going to UT, in UT, the JavaScript UT is that we lack JavaScript viewpoints. What is inside in our unit testing? Our unit testing has server-side test and client-side test. For server-side, it was planned in our iteration 9 that we use the JUnit testing. The JUnit testing cover only the server side. However, for the client-side testing, we use the GUI behavior check. We performed this testing, however, it was not enough. It was lacking some viewpoints. Viewpoints like validation, range check, parameter check, and GUI element triggering. So, analyzing further our unit testing, we found out that our unit testing, the viewpoint for JUnit covers the whole server side. However, for the GUI behavior checking, because it was lacking, it does not cover 100% of our unit testing. So with the unit testing, we have to go further. We have to go to the detailed design, and this we have found the root cause. We found that in our detailed design, in the creation process, we lack JavaScript detailed design viewpoints. And this is the root cause of our problem. So with that, the project tried to set targets. We set first target of ours was detection of short-term goals, and second is prevention, which is called the long-term goal. Now we call detection as a short-term because since milestone 2 and 3 are already ongoing, and we can no longer go to the upstream phases, we have to deal what is already the current phase. And our target is to improve detection of JavaScript bugs at the earliest possible phase on the current schedule. And for prevention, we try to prevent the spilling over of JavaScript bugs on the IT phase. So for our short-term goal, we try to improve UT bug detection. By improving our UT bug detection for JavaScript, we increase the detection for JavaScript bugs in unit testing. And by doing so, we decrease the JavaScript bugs found in IT. And how are we going to do this? What we are going to do is to use the BD document as our reference. So we try to add additional test items in order to reinforce our unit testing. Now BD document does not really specifically describe the JavaScript, the viewpoints. However, it still describes the overall client behavior, and we can still use this for our UT specs. And by doing so, we now reinforce our unit testing. For our long-term goals, we try to prevent the spilling over of JavaScript bugs on IT. In order to do this, we have to detect JavaScript bugs before IT. So we try to set targets of 50% JavaScript design defect detection in detailed design, 30% in coding, and 20% in unit testing. By doing so, we can ensure 0% JavaScript bugs in integration testing. So the action plan for this is that we are now going to reinforce again our detailed design. We are going to use a new template which will now have flowcharts, truth tables, decision matrix, value range definition to define behavior of JavaScript functions for each web page. And by doing so, we now have 100% coverage for our DD template, for our DD. So we already started implementing this solution of ours. But during at March 13, we already have our UTS scope enhancements. For this May 20, we plan to add JavaScript test guidelines and test plan and update DD template and DD creation guidelines. So, partial evaluation for our short-term goal. Was our solution, was it effective? Yes. Yes, it was effective because during milestone 2, the planned UT bugs was 8 and the actual UT bugs was 7. And 6 of these 7 bugs are JavaScript related. So as you can see, if there was no additional test items in UT, these 6 bugs will spill over to the integration testing phase, and this will cause a lot of problems. So the benefits are clear. For quality, this solution ensures us early detection of JavaScript defects in upstream phases. It eliminates JavaScript bugs in integration testing phase. For cost, this solution of ours reduces code rework in IT, and as a result, it increases IT productivity. And finally, for delivery, this solution of ours ensures release on time. So, with that, that was our SWQC story. I'm Jerard de la Victoria from the SWE Portal Group. Thank you very much and good afternoon.